It is the 5th of March, Fun Sock Friday. You guys will be able to use and understand.
No, it's identify.
Identify and use properties of special right triangles. Thank you. Section 7.2. Special right triangles. Okay, that's what we're going to talk about today. Now here, on 1, what do we know about this triangle?
There's only one length.
Okay, we know one length.
Isosceles. You know both.
Oh, we know both because it's isosceles. We're told 2 are congruent. So what's the other length? What's the other leg? 3. So we know both legs. Would we be able to find the hypotenuse?
Where can I get one of those 7 things that we should
Ask Jacob Z-Tech.
Okay.
All right.
I need one of those.
Could we find A?
Yes.
How?
3 plus 3.
Nope. Pythagorean theorem. How do we do the Pythagorean theorem?
3 squared plus 3 squared equals
3 squared plus 3 squared equals
8 squared.
A squared. Let's do this with me, please. What is 3 squared plus 3 squared? 9 plus 9 equals A squared. What is 9 plus 9? 18 equals A squared. Now what do we do? Square root. Is 18 a perfect square? No. It says in simplest radical form. So that means we put it in our calculator and let it do the work? No. It means that we actually have to do the simplifying ourselves. So, is there a perfect square that is a factor of 18?
9.
9. It is the square root of 9 times the square root of what? 2 equals A. Now, what is the square root of 9? What did that help? It's 3. So this is 3 times the square root of 2 equals A. So that's what we end up getting. And you guys see this nice little box down here? All right, for number 1, what are we going to put in for the leg? 3, what are we going to put in for the hypotenuse? 3 times the square root of 2. 3 square root of 2. 3 radical 2. However you want to say that. Probably not. All right.
It's radical, though.
It is. I want you guys to do the others. Guys, I want you to do 2 through 6.
I got this.
Let me know when you have more questions. All right. On number 2, this leg was 4. As we set up our Pythagorean theorem, we end up having 4 squared plus 4 squared equals b squared. 4 squared is 16. 4 squared is 16. 32 is equal to b squared. We square root both sides. Now, 32 is not a perfect square. Nothing times itself is 32. But there is a factor of 32 that is a perfect square. What is the biggest factor of 32 that's a perfect square? Gregory? 16. So the square root of 16 times the square root of 2 is equal to b. Because 16 times normal 2 is normal 32. So the square root of 16 times the square root of 2 is equal to the square root of 32.
Why sit something top?
What?
Investigating special right.
Yes. So, that's what we're doing. So, what is the square root of 16? 4. That's why we chose square root of 16 there, because it's normal 4. Not under a square root anymore. Is equal to the square root of 2. So we're going to fill out our table. My leg is 4. My hypotenuse is 4 times the square root of 2. As we went on to number 3, we said, oh, this length is 5. 5 squared plus 5 squared is equal to c squared. 25 ha 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 plus 25 ha 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 is equal to c squared. Well, that's 50. And we need to square root it, but last I checked, 50 is not a perfect square. But is there a factor of 50 that is? Yeah. As a matter of fact, one is a pretty funny one. The square root of 50, 25 times the square root of 2 is equal to c. Now, this helps us because what is the square root of 25, guys? 5 times the square root of 2. So we go down to our table. We put in 5 as our leg. We put in 5 times the square root of 2 as our hypotenuse. Questions on those 3 so far?
3.
All right. Let's look at 4. The leg was 6. So to find the hypotenuse, 6 squared plus 6 squared equals d squared. 36 plus 36 is equal to d squared. 72 is equal to d squared. Square root both sides. And we end up getting the square root of what times the square root of what is 72? 36 and 2. Very good. 36 is the highest perfect square that goes into 72. And what is the square root of 36? It is 6. So this becomes 6 squared root of 2 equals d. So we go here and we say, what's the leg? It's 6. What's the hypotenuse? 6 squared root of 2. Are we noticing anything?
Pattern.
What are we noticing? What pattern are we noticing?
The leg,
The hypotenuse
one
is-
leg to the square root of 2
So you-
equals the hypotenuse.
So you take a leg and you do what operation with the square root of 2?
Multiply.
Multiply. So you take a leg, you multiply by square root of 2, and we're getting our hypotenuse. Is that going to hold up on our last two?
Yeah.
Let's check. So what do we think the hypotenuse will be on number 5?
7.
And the square root of 2.
7 times the square root of 2. Not to the, it's not to a power, but 7 times the square root of 2. Well, let's check it out. 7, so 7 squared plus 7 squared equals e squared. 49 plus 49 is equal to e squared. What's 49 plus 49?
Shouldn't it be equal question mark?
You could do equals question mark. You could do equal x. It's called e right now, so I'm just calling it e.
Well, no, I mean,
Oh, we're asking if it's equal? Great question. So are we asking if it's equal here? No, because it's the right triangle, we know it is. When we didn't know what type of triangle it was, and we were trying to figure out, we asked the question. Yep. And so this was 98 is equal to e squared. We square root both sides. And what's the biggest perfect square that goes into 98? 49 times 2. Oh, we might have a pattern here. What's the square root of 49? 7 times the square root of 2 is e. So it did follow that pattern we thought it would have. So according to that pattern, what's this last one going to be? 12 times the square root of 2. And it is that.
That'd be great.
You end up getting the square root of 288, which is the square root of 144 times 2. Square root of 2, excuse me. Yes, Kenny?
it would have been great if you threw us a curveball there. This is something completely different.
Psych. Guys, this pattern is something that actually is a special right triangle, hence the investigating special right triangles. And notice how it says a 45, 45, 90. Well, let me ask this, guys. In an isosceles triangle, what do we know about those two angles opposite those congruent sides?
Equal.
They're congruent as well. If these other two angles are both congruent, and one of them's 90 already, what's the other two angles both have to be? 45. So this is what we call a 45, 45, 90 triangle when we're talking about the angles. Hence the 45, 45, 90. So we have this theorem right below. In a 45, 45, 90 triangle, or it's also considered to be an isosceles right triangle, because it's an isosceles triangle that is also a right triangle. Yeah, Gregory? In 1 second. The hypotenuse, you could abbreviate it HYP if you want. Hypotenuse is blank times as long as each leg. You tell me.
2.
Nope. It's not 2 times as long. It wasn't 2 times as long. It wasn't 3 and 6, 4 and 8, 5 and 10.
1 leg times the square root of 2.
It is square root of 2 times as long. It is weird to say. It's square root of 2 times as long as each leg. We're going to draw up a little map here. So let's say this leg is X. What do we know about the other leg? They're the same because these are 45, 45, 90. So these sides are congruent. So this is also X. How would I go from the leg to the hypotenuse?
Straight.
X multiplied by the square root.
Multiply by the square root of 2. Very good, Landon. So what is X times square root of 2? Just X times the square root of 2. Now, if I wanted to go back, let's say I was given the hypotenuse first. Well, how would I go back? How would I undo that? What do we think? Divide by the square root of 2. So if you're given the leg, could you find the hypotenuse?
Yes.
Yes. If you're given the hypotenuse, can you find the leg?
Yeah.
Somehow
Yes.
it's gonna happen that way.
Now, so if you only know one side length, is that enough to find the other two? In this type of triangle, yes. In our other triangles, we needed 2 side lengths of a right triangle to find the third. In a 45, 45, 90, if you know one, you can find the other 2. I want everyone to draw this exactly like I have it.
You already know.
What's going to happen is, when you guys ask questions, I'm going to say, hey, let's go back to our map. Because that's what I'm going to call this, a little map. We're following directions. Say, hey, where do we start? Where are we going? What do we do?
Where are we?
And I say, oh, we're starting with leg. And we're going to hypotenuse. Okay, let's follow the arrows. How do we get there? Oh, we multiply by square root of 2. Oh, we're starting at hypotenuse and we're going to leg. Follow the arrow. Divide by the square root of 2. I'm going to ask you to pull out your map every single time you ask questions on this. Because I want you to remember this. And so if you don't have your map, I'm going to say, well, that's too bad. You probably need to write down your map. Then I will help you. Am I saying I won't help you at all? No. I'm saying, hey, do this, then I will help you. Help yourself, then I will help you. I have students every year that write this down as soon as they get their test. Because then they can use it throughout the test.
That's a pro gamer move.
That's a pro gamer move. That's big brain. Is that something you guys could do?
Bigger mind.
Definitely. Can you memorize this long enough to draw it on a test? Probably, especially if you do that as soon as you get the test. Even before your name. Or after your name.
What's not your name? My name
Okay, Greg, go to the restroom.
My name is Moose.
Good luck.
My name is this triangle.
Questions on that? All right. We're going to utilize this. Letter A. Solve for x without using the Pythagorean theorem.
I got this.
Go ahead. Solve for x. Don't blurt. Let's talk about this up here. What type of triangle do we have on letter A? That's my first question. Isosceles right. Otherwise known as a, what do we just call it? What did we just call it a moment ago?
Right triangle.
We called it isosceles right. We said it's a what based upon the angles.
45, 45, 90.
Thank you, Seth. It is a 45, 45, 90 triangle, okay? Because these are 45 degrees each. They have to be. In a 45, 45, 90 triangle, we are given what part right now? We're given the leg. We're trying to find the what? Hypotenuse. According to our map, how do I go from leg to hypotenuse? Multiply by the square root of 2. So I write 18 times the square root of 2. Can I do anything more with that?
Yes.
You could.
Equals X.
Equals x. That's the answer. That's literally the answer.
If you're okay.
That's it. Do we need to use the Pythagorean theorem on this?
No.
No.
It says you can.
You can use it.
You can,
It's exactly
but do you need to?
It says you can't because it says without.
It says doing it on this problem without, yes. On a problem like this, do we need to use the Pythagorean theorem? No. Could this save time? Yes.
It's literally no.
What do we have to do for it to save time, though? We have to know what we have. We have to spend time analyzing it. We have to take a second and think, hey, what do I have? Oh, I can do my shortcut. My map tells me how. Seth,
So what if I was like an equilateral triangle?
It's not the same.
if it's equilateral, it couldn't be a right triangle, so we wouldn't be in this scenario.
I know, but what would you put in the...
So Seth, we wouldn't be in this scenario at all because it couldn't. If it's an equilateral triangle, you can't use the Pythagorean theorem because you only use the Pythagorean theorem for right triangles. And equilateral is equal angular. All right, letter B. What kind of triangle do we have? That's what I'm going to ask every time here. What kind of triangle do we have?
Not left, but right.
Isosceles right, which we also call a
44, 45, 90.
45, 45, 90. You guys are going to really have to get used to that term. 45, 45, 90. I want everyone to say what type of triangle this is.
45, 45, 90.
I want all of the class, not part of the class, to say 45, 45, 90.
45, 45, 90.
Perfect. What side are we given in a 45, 45, 90 this time? The hypotenuse. What are we trying to find? The leg. How do we go from the hypotenuse to the leg according to our map?
Divide.
Divide by the square root of 2. So let's write that off to the side. 18 divided by the square root of 2. I'm going to write that a little bit lower, actually.
You said we're gonna do something else.
Yep. Now, the other day, in section 1, we said...
Whoa, buddy.
Whoa, buddy. I wrote that wrong. Thank you.
Whoa there.
Okay.
Do we like that square root on the bottom? No. So what did we do the other day?
Divided by itself.
We multiplied by
Square root of 2.
Square root of 2. 1.
1. So what did we say was our 1 in parentheses? Or in quotes, excuse me. Seth.
The square root.
We would do the square root over the square root. So in this case, the square root of 2 divided by the square root of 2. Because what is literally anything in the world divided by itself?
No.
1. So we multiplied by 1 with our air quotes. And now, why did we choose the square root of 2 instead of the square root of 5? Seth.
The square root, because you wouldn't get 1 if it was not itself. It was square root of 2.
Well, if we chose the square root of 5 over the square root of 5, that'd be 1. So why does this help us to choose the square root of 2 over square root of 2 rather than choosing the square root of 5 over the square root of 5? Why would that not help?
But it's not even part of the problem.
Let's see what would happen here. We would have 18 times the square root of 5 over the square root of 10. 2 times 5. Does that help our scenario?
No.
Why not? Is the square root of 10 a perfect square?
No.
No, it didn't help us.
It made it worse.
It made it worse. I picked the square root of 2 because that's exactly the square root that's on the bottom. This one's going to have us get to 18 times the square root of 2 over the square root of what? 4.
2.
Does that help us? Yeah, because what is 4?
2.
2. 18 times the square root of 2 over 2. Are we done?
No. It's simplified.
No, we can simplify. What is 18 divided by our normal 2? They're both outside the radical. I can divide those.
It's 9.
It is 9. So this becomes 9 times the square root of 2, and that is our x. That is our answer.
Yes.
Is that just one leg or is that both? That's both. Questions on that?
You get that bread gluten.
What about gluten-free?
Get that bread gluten free.
Oh, the bread we're getting. My wife would need it to be gluten-free.
That's basically the whole bread.
But, no.
No, wait.
She,
She's allergic to
no. He's also not allergic to peanuts or shellfish. Are you going to ask other random allergies?
She's allergic to bread itself. Grass?
Some people are.
I know
Some people are allergic to everything outside.
Yes, Tyler.
Yeah, that's what I mean.
Didn't you go earlier? I said you could. What? I said you could.
No, you told him to wait.
Okay, I'm just using this slide as a blank space to write these. I want you to do problems. 2, 4, 5, 7, 9. Let me think here. 12, 14, 15, and 17. Once you have that or take a picture of it, you are good. I would pack up because we are on time. Out of time.